This is problem number 4 from section 2.1. In this problem, they want us to find the slope-intercept form for the line passing through 5, 2, and parallel to the line passing through these two coordinates. So this problem is a little bit longer process because we have to find the equation for the original line from these 2 points. So we're going to say use these 2 points to find and we really don't need the equation, so we need the slope of the original. So we want to use those 2 points to find the slope of the original line. And then we want to take that slope and we want to use that slope because they asked for a parallel, and we know parallel lines means we will use the same slope. Okay, so these are important pieces of information that they just gave us. And we want that to go through this new parallel line to go through the coordinate 5, 2. Okay, let's start by using these 2 points to find the slope of the original line. So that means if we want to find slope, we're going to use this equation. So if we do y2 minus y1, I'm going to slide this down just a little bit, and we're going to go ahead and say y2 minus y1, so we'll say 4, 5, and negative 2, 3, and I'm going to label these. This is my first coordinate, so I'll say x1, y1. This is my second, so I'll say x2, y2. The 1s and 2s just distinguish which coordinate is what. Then we'll start with y2, so we'll start with 3, and we'll say, let's go with 3 minus y1, which is 5, over x2, which is negative 2, minus x1, which is 4. This gives you negative 2 on top. On the bottom, you end up with negative 6, so we end up with a slope of 1/3. So we have a slope of 1/3 for our original line. So this is the original slope. And maybe we'll write that here. This is original slope. Okay. Now we want the new slope that's parallel. So let's go ahead and write parallel slope here. And the parallel slope is going to be 1/3 as well, because we know parallel means we use the same slope. So we're going to have 1/3 here. So m equals that. And then we need to use the coordinate, so we'll say coordinate, and this is 5, 2. So let's go and use point slope form to do this. So if I pull out point slope form, I can now use this by calling it x1 and y1, and I use that slope. I can now write my parallel line that goes through this coordinate. So I say y minus y1, which is 2, equals 1/3 x minus x1, which is 5. Distribute, I get y minus 2 equals 1/3 x minus 5/3. Add the 2 over, I get y equals 1/3 x minus 5/3 plus 2. If I rewrite 2, I can rewrite that as 6/3. So y equals 1/3 x minus 5/3 plus 6/3. And we end up with y equals 1/3 x plus, well, that'd be 1/3. So this is the equation that is parallel to this original line. Now, I didn't write the whole line out, right? In order to write this whole line out, we'd use one of these coordinates and write the equation. But I know that it's parallel because they have the same slope. So I know I'm good because this equation has the same slope as the original, and it goes through this coordinate 5, 2, because that's what I used to build the equation.